Um, Hello, welcome to another lecture in Principles of Finance. This is Dr. Jeff Holm, and today's topic is time value of money and compounding. Now, we already understand a lot about compounding because we started out with the example in compounding. And um, time value is, you might think this is a new concept, but actually, this is not a new concept because we all understand there is value associated with time. Um, in other words, compounding is a process that clearly uh, indicates that there is a trade-off, right, between today's $10,000 and the future value of today's $10,000. In other words, if you do not spend $10,000 today, that means you're foregoing the consumption that the $10,000 can provide for you, right? So then, if you are, instead of spending $10,000 today, and when you spend, basically consumption is contributing to the enhancement of your utility, which means your, it's also called, felicity or satisfaction, right? But you could use $10,000 on a on a holiday cruise or vacation today, or you can save it for tomorrow. And if you are saving it, right, then you're trading it off. You're trading today's consumption off with bigger return in the future. Obviously, you won't trade off today's consumption of $10,000 with tomorrow's consumption of $10,000, right? I mean, if you're putting it off for 1 year, that means you're putting it into something like some savings instrument like CDs for 1 year. And obviously, you're not going to do this for free, right? I mean, you are sacrificing today's, gratification. I mean, we are putting off instant gratification for a bigger gratification 1 year from now. Meaning, if the interest rate is 10%, 1 year from now, it's going to be $11,000, right? That's the future value. You're trading off, and as long as there is no inflation, right, between now and 1 year later, then 1 year later, you'll have 10% more purchasing power, right? So you will, just, rough, I mean, the reality is not like this, but, if you can consume 10% more, your utility or satisfaction will be 10% greater, right? It's a trade-off, Some people cannot wait for a bigger reward in the future. I mean, this is a famous, psychological experiment. You gave, one group, there are like, 10 kids in a room, and you gave them like 5 marshmallows, and you told them, uh, you told them that you will leave the room for 1 hour or 30 minutes, and when you come back, if the kids haven't eaten the marshmallows, then they will get twice as many, right? They will get the reward, right? Uh, and so the researcher left the room, and the 10 kids were left with 5 marshmallows, and some kids waited. They held out, right? But some kids couldn't. They ate up marshmallows. So what does that tell? People who are, there are people who have propensity to, these are kids, they don't have any logical or, thinking. They just live by intuition, they would just, and some kids can visualize. Some kids can, understand that they will have 10 marshmallows if they just hold it out for, 30 minutes. Some kids cannot even visualize that future. They live for instant gratification, and that's also true. I mean, this experiment was with kids, but with adults, you see the same, still the same result. Some people cannot make sacrifice today for better tomorrow. That's why there is crime, first of all, because they cannot see themselves, I mean, if they commit a crime, just, a few weeks down the road, a few months down the road, they cannot see the consequences, right? They cannot make that connection. But anyway, so there is value associated with time, and we know that $11,000 in this example is the future value, right? And that $10,000 is the principal, and from if you're standing in the future 1 year from now and looking back at today's $10,000, that's called present value. And this this example is something we already did in topic 1. But let me, I already put it here. Well, let me, but let me just, reiterate it. Let me first stop sharing the PDF file, and then let me go to, let me switch to, okay, all right, this is a Word file, but, I want to use this draw, right? So basically, we all know that we did this in topic 1. Oops. I thought okay, draw. Now, let's say we have principal, which is 10K, and the interest rate, let's call this, R, and then which is 10%, and then time, let's say 5 years, right? And then our question is, what's it going to be in year 5. In other words, what's the future value in year 5? Oops. And then we know the process already, right? First of all, starting from year 1, at the end of year 1, we know there's going to be $11,000, right? But then the process, if I this is like, all over again, showing you this process. $11,000 is the result of principal plus interest, isn't it right? And interest can be rewritten as, I'm not just first, principal. Interest is can be written as P times R times T, isn't that right? Interest is the result of principal times interest rate times time. In this case, T is 1, right? So you don't have to write it because then, because it's 1, you don't have to write it. And then we know when there is a common factor, you need to factor out to make it, to simplify it, to make the expression the simplest possible. So if I factor out common factor P, right, then you're left with P times 1 plus R, right? Now, then what is, and we know it is, $11,000 already, because even without doing this, it's very easy. But if you want to plug in the numbers, like, this is going to be 10,000, right? This is 10K. This is 10K, and this says 0.1. In other words, 10%, right? 0.1. So the whole thing is 10K times 1.1, so it's going to be 11K, right? Now, then FV2 is following this process. FV2 is the future value at the end of year 2, right? So at the beginning of year 2, then what is sitting there? Is principal of 10K sitting there? No, we know already there will already be 11K sitting there, which is, FV1, right? Right, and then FV1 will earn interest for 1 year again. So 10% of 11K, so that's going to be 1.1K. But again, because interest is the result of multiplying FV1 by R for 1 year. So I'm not going to write, I'm not going to do multiply it by 1 again because it's 1, right? And then, so In year 2, you have already a future value 1 sitting there, and then which is 11K, and then future value 1 is earning 10% interest, right? So 10K times 11K times 0.10. Now you can factor out the common factor, which is FV1, and then you have 1 plus R in the parenthesis. Okay. Now then, we can break down this FV1, because what is FV1? By definition, FV1 is this, P times 1 plus R. So I can rewrite FV1 by its own definition, which is P times one plus R, right? And then there is 1 plus R here, so another 1 plus R times 1 plus R, and then we know better than this. We don't write it like this. When we have 1 plus R times 1 plus R, so we already know we should write it like P times 1 plus R squared, right? Okay, hence we find FV2 this way. What about FV3 then? We don't have to go all the way to FV5, but let's just try this. Then future value at the end of year 3, then the same process. At the beginning of year 2, you have, at the beginning of year 3, you have FV2 sitting there. And FV2 is, by the way, think about it. We have FV2 is 12.1K, right? Because 11K was there at the beginning of year 2, and it earned 1.1, 10%, which is 1.1K. So it's going to be 12.1K. So FV2 was sitting there at the beginning of your year 3. Okay. And then it earns interest for 1 year. And again, through the same process, FV2 plus FV2 times R. And then by, factoring out the common factor, FV2, and times 1 plus R. Right? And then we know FV2 is basically what? FV2 is P times, we're just replacing it with its own definition, right? Replacing it with, the definition of FV2. That's FV2. And then we have 1 plus R again. So then what does this become? This becomes P times 1 plus R raised to the 3rd power. Okay? Now, need I go further? Need I go more? We already know there's a general rule here, governing rule here. In other words, this is time subscript, right? So for whatever future value, right? Let's say future value at time n. right? Future value at time n, and being any number, right? That future value will be simply p times 1 plus r raised to n, right? Okay, so this is called compounding, right? Finding the future value, right, through compound interest or compound return process. And we already know this. I mean, this is nothing new. I mean, we already talked about compounding at the in the first topic, right? So let me switch back to the PowerPoint, and let me go back to yeah, which is actually PDF. I mean, I made PowerPoint and saved it as PDF. Now, so this is our generalized, this is our generalized formula, but this model is called a single cash flow model. Okay, I'm gonna get to that definition later, but also you might wonder in the Word file where I drew the steps of derivation. The exponent was n. Why is it t here? Look, t is just generic notation for time. Okay, and time can be and time can be in many different units, but n is such as years, months, weeks, days, so this is just a generic notation just to represent the future value is the present value compounded in time periods, and n represents actual number, right? Number of periods. So our next question is, and this ties in together with our next question. So t can be simply replaced by n, and the reason we are talking about it at this point is because compounding doesn't have to be necessarily only annual, right? So far, our assumption was compounding happens once a year, right? Because of course, normally, if you put your money in the bank, you think you are earning interest annually. And that's normally the case, but it doesn't have to be just annual, right? In other words, compounding doesn't have to be annual. Compounding can be at a more frequent time interval. In other words, let me introduce additional variables, right? First of all, R, let me go back to the Word file and So let's go to how do I? Yeah, I'll have to. Um, oh, okay. Oh. How do I? Okay, so I need to. This is ridiculous. This is crazy. So I think I'll have to. Okay, so let's think about it. We need to introduce a couple of new variables. One, oops, what's going on here? APR. And what is APR? It's nothing new. It's annual percentage rate. In other words, APR is annual interest rate. We've been taking it for granted. I mean, we've used R as the annual rate, but the rate, as I said, compounding doesn't have to happen only once a year. It can happen at any interval. For example, where's my? So I'm introducing a new symbol called M. And what is M? It's the compounding frequency per year. So compounding frequency means, if it is annual compounding, it's once a year, right? If it is twice a year, that's semi-annual compounding, meaning, every 6 months. And then there can be quarterly compounding. Quarterly compounding literally, every quarter. So that's 4 times a year, right? And then if the compounding frequency is 12, what does that mean? Monthly compounding, right? Every month. And then 365, what does that mean? Compounding happens daily. So then, how does this work? Look, if let's say APR is 6%, annually 6%, right? But then if compounding is once a year, of course the APR is exactly the R, the rate, right? But if compounding is twice a year, what does that mean? Every 6 months, you earn 3%, right? Because so first 6 months you earn 3%, and in the second half of the year, you get another 3%, but that gets compounded. In other words, what you have already earned, 3% that you have already earned becomes part of the principal in the second 6 months, in the second half of the year, and then it earns 3% again. So in that case, if it is 2, then R is 3%. We know it is APR divided by M. Okay, so the name, so M is the compounding frequency, then R is called periodic rate. Periodic rate. Okay. Now, what happens? So if R is 12, right? I mean, if M is 12, meaning is monthly compounding, then what's going to be R? Of course, then 6% over, right, APR over M, 6% over divided by 12. So it's going to be 0.5%, right? 0.5, right, or 0.5, 0.5, right? So then think about it. How many compoundings, I mean, if compounding frequency is 12, what does that mean? How many compoundings happen per year? 12 compoundings. And if M is 4, what does that mean? That's quarterly compounding. Right? Then R would be, again, 6% divided by 12. That's going to be 1.5%. Now, then, suppose we have our time is 5 years. And then if compounding is M is 4, if M is 4, right? So how many compoundings happen over 5 years? How many compoundings happen over 5 years? Annually 4 compoundings, so over 5 years, right? 4 times 5, right? In other words, M times T, right? M times T, right? So in our example, it's going to be 20 compoundings, right? And this is called N. Okay, so N is the actual number of compounding. N, right? T is just, generic notation for time and usually years, but N is the actual number of compounding, right? So if we rewrite the same problem, right? So principal, let's try that. Future value N is P times 1 plus APR over M raised to T times M but then this is once again back to P times 1 plus R raised to N. But this time, R and N are different. In other words, previously, R and N, R was, if P is 10K, our APR was 6%, APR. %, and T was 5 years. Okay. But then when compounding frequency was 1, in other words, annual, then you would write future value will be 10K times 1.06, right? 6% is 0.06 raised to 5, right? If M is 1. But then, if M is 12, then, if M is 4, it will be 10K times 1.015, right? 1.5% is, right? And raised to 20, right? If M is 4, compounding frequency is 4. In other words, if compounding is quarterly, right? So now this is how we can tweak the the basic compounding formula, right? To adapt to different compounding frequencies. All right, so that's it for this segment of the video, and I will see you in the next video.